it's definitely going to be hard. There's definitely going to be moments when you're like, why aren't they listening to me? You're going to have to do a lot more extra work, which really sucks. And it's also sort of product to be in the field. But don't be scared to like speak up or say something or be confident in yourself.
Yeah, that and you will find your people. There's a very strong community for women in STEM, women in engineering, women in SAE.
Hi, I'm Emma Zareen, your host and a 16-year-old engineering student, policy enthusiast, and hopeful future STEM school survivor. Welcome to She Persists. Before we dive in, I just want to take a second to say how grateful I am for each of you. Every listen and every bit of support genuinely means the world to me. When I started She Persists, it started as a little dream to share real stories of young girls in STEM who are challenging norms, finding their place, and inspiring change. Seeing that idea come to life has been so rewarding, and honestly, it's just the beginning. If you've been enjoying these conversations, I'd love for you to be a part of our community by following this podcast. It's one of the best ways to help us grow, share even more incredible stories, and connect with a wider audience. And I hope the conversation doesn't end here. I hope you carry these stories with you and let them be a constant reminder that your voice truly makes a difference. In today's episode, I'm joined by Emma Wolf, Ariella Labova, and Dhrithi Chichilla, three women from Illini Electric Motorsports at the University of Illinois Urbana-Champaign who are helping design and build a fully electric Formula-style race car from the ground up. From embedded software and vehicle diagnostics to integration systems and high-voltage powertrain design, each of them plays a critical role in making sure their car not only runs, but performs at the highest level possible. Throughout this conversation, we talk about what it actually takes to build an electric race car, from managing data from dozens of sensors to designing lighter battery systems and making trade-offs between performance, reliability, and time. They share what it's like to work in one of the most demanding and collaborative engineering environments in college, and how attention to detail and communication can make or break an entire system. We also talk about the bigger picture, finding confidence in male-dominated spaces, dealing with imposter syndrome, and building strong communities of women who support each other through long nights in the shop and tough engineering challenges. One of my favorite parts of this episode is hearing how each of them found their place on the team, often by stepping into uncomfortable situations and learning to trust their own voices. This episode is such an inspiring look at teamwork and resilience. So with that, let's get into it. Here are the girls of Illini Electric Motorsports. Emma, Ariella, and Dhrithi, welcome to She Persists. I'm so excited to have you guys with me today.
Thank you so much for having us. We're very excited to be here.
Yeah, I'm so excited to have you guys. So before we get into your individual roles, I just want to set the scene a little bit. You're all on the same Formula SAE team. For people who don't know what that is, what are you actually building and why?
So basically, we're a student-led club at the University of Illinois, and we build a fully electric vehicle that kind of resembles a Formula One car every single year from scratch. So basically, our season is split into two parts. The fall semester is design season, and then spring semester is manufacturing season. And then we compete with our car every summer at the Formula SAE EV competition against teams from across the world. A lot of teams from the US as well as Singapore, Brazil, things like that.
Yeah, that's so cool that you guys are doing that. How did each of you guys end up at Formula SAE? Was it something that you always knew you wanted to be a part of coming into college, or how did you kind of end up there?
I can start. I think it sort of happened by chance for me. I know there's a lot of people on the team who were first on first robotics and then ended up going to Formula SAE. There was a big shift for that. I had some friends I made at the beginning of my freshman year, and they were also interested in Formula, and I decided to tag along, and then I ended up sticking around because I really love the people and love the things I was doing. So that's kind of how I ended up here.
Yeah, that's awesome.
I have kind of a similar story. I knew that I wanted to do a technical club going into college because I didn't do anything technical in high school. So I went around to different teams on our club day and talked to different teams and got a feel for them. And I really liked Formula SAE just because of how committed everybody was and the opportunity to learn about everything from start to finish, which I think is pretty unique about our team specifically.
Yeah.
As for me, in terms of engineering, had interest and some experience on the technical side, but I wasn't really sure what I wanted to do or how I wanted to engage in such activities in college. So it's funny that even though I had that intention, I kind of up here in like the most random ways. I ended up on the team by tagging along with friends, obviously. And it's funny that it seems to be the most common way that people because really when you end up putting so many hours and commitment, you feel inspired by something, and it's usually the commitment of the peers that you work with, and then the people who are above you who have that passion that they instill into you to continue to work on that. So yeah, I joined the club by randomly walking into a garage one day while they were not even kidding, because I hadn't even gotten into like an introductory meeting. I walked into a garage and we were making a ergo jig to make measurements that were necessary to make sure our driver fit comfortably in that cockpit. So that was really interesting. People were so excited. So many people were really passionate on getting work, and there was a bit of fighting, and that's always motivating. Most importantly, I think the main reason I stayed in this club is I thought there were some really cool people on the club who just seemed so passionate in teaching and learning. Sure, exactly. The fellow freshman with me. And so, yeah, that was how I joined.
Yeah, I think that's so awesome that you guys are all able to find that community and so early in your college careers too. So I think that's really cool, and that's nice that you guys were able to join that organization. But what's something about Formula SAE that you guys think people might not know before joining the club that you think would be helpful to know if someone was interested?
Most important thing to know is like you sort of get what you put into it, like you get out of it what you put in. So there's like a lot of people who show up all the time, and you see the most like they like reap the most rewards in terms of like what they learn and everything. Not to say that you can't, participate a little bit less, right? Like you still do learn a lot, and I think that's one of the awesome things. But I think it's like it's definitely a very time intensive club, but it's really worth it, and I think it's almost easy to put that much time in because of the people you're surrounded by.
What I would say is that, like, it's okay to be awkward. I think that a lot of times, like me especially, I came in like not knowing anything at all. And it felt really weird going up to people and asking for work, especially people that like I admired because they were older than me. And like, I was like, wow, they know so many things. But like, those butterflies is like really important, and being able to push past that and asking for work and asking questions and making that jump, that really gives so much benefit, and it allows people to know how hardworking you are.
Yeah, and I totally agree with that. I can definitely relate to that too. Just like being in an environment where you don't know everything and it seems like everyone knows what they're doing, and just having to like force yourself to ask those questions. I think that is where the most growth happens though. So I think it's always important to just push yourself to ask those questions and get the help that you need. Something like you think would be helpful or inspirational to someone, I guess, who wants to join SAE.
I think if it was for an essay club, my answer would be different than if it was for this club specifically. I think for any essay club, the actual car to involve yourself in a club that can create a car and compete and make it meaningful. In fact, in the competition is quite high, I'd say. And so it's both a little devastating and also highly rewarding. I've thought about the actual premise a bit because of that. It's like high cost, high time, high reward kind of thing. And that's why you see that there's quite a discrepancy in like the colleges you see that generally perform well in engineering that succeed in the competition. Specifically for our club, I really, really like that they stick to the motto that you get what you put into it. It's because literally no one can make you do anything, and we don't expect anything in return. Everything you do is made from your initiative, and we recognize that like interest, passion, and intellect, and then we try to help that grow, I guess. And so I think that's kind of like the responsibility the people in the club like assume to help that passion and intellect grow, and who also like help that person grow. I think there's also that side because we constantly say that we're inspired by the people that we work with and work for. So yeah, I think that's what I like about this.
Yeah, I think that's really awesome. I feel like what you just said, it's nice to be inspired by the people you're working around and working for. I think that's such a big thing. A lot of the times we learn the most from people who are just a couple years older than us, which is also part of the reason I started this podcast. So I thought it would be cool to hear from like girls in college who are still working their way through their careers. But yeah, great answer. I love that. So you guys are all on different sub teams. What does a typical meeting in the shop actually look like for you guys?
I guess I can start again. Like I am involved in like a couple different sub teams. Like I'm technically the project lead of like three. But like in terms of like more the electrical like software and low voltage systems, there's a lot of I think just kind of sitting with your computer out working on things. And then like once you like finish what you're working on, there's a lot of testing that you have to do from the things you worked on your computer. And we have like, a bunch of different like electrical benches and there's also always like a lot of people around and you figure out what you're like having to test or having to make like and then you kind of just have to sit down and do it and then there's a lot of just kind of like stepping through code and debugging and just kind of like it's definitely pretty tiring, but because like there's so many things to work on the shop at all time, like it's pretty easy to take a break and like find other things to work on, even if it's like, not something that you're like strictly like part of, for example. Like I'm sure like if I ever saw like anybody working under Ari needed any help in the shop and they were asking and I was like not necessarily doing something like that'd be something I could just like help with.
Yeah, that's a great answer. I'm on an FRC team right now, so I totally relate with what you just said, like jumping between the sub teams and finding ways to help everywhere. I'd love to talk a little bit more about your individual roles on your team because all the work you guys are doing is so incredible. Is it okay if we start with you, Emma?
Yeah, sure.
Awesome. So you're currently leading vehicle diagnostics. What does that actually mean on an electric race car? So like what are you diagnosing and why does that matter?
If you're driving in just like, a normal car and let's say your gas gets low, you get a little light that pops up on your dash indicating you have low gas or if you have low tire pressure, any of that. We're essentially trying to implement that like both it's like literally we're using the exact same protocol and also like at kind of a higher level. That's what we're trying to implement. It's sort of like a system that we can implement to make it a lot easier to know what's going on within the car because we do have like a data pipeline already, right? But it's a lot more extra steps and we're kind of trying to reduce the jump from like something is wrong with the car, we have to go look at all this data to like something is wrong with the car. I want to just be able to look at the car really quickly and see what the issue is. So it's making the point of entry for like diagnosing what's wrong with the car a lot easier. So like pretty much like having our own like, check engine lights and stuff like that.
Yeah, that's so cool. So how did you initially get into this side of the race car or I guess the coding more that side of the race car?
Is like coming out of high school into college, I was always like pretty interested in CS. So I think part of it was sort of like defaulting to doing the software because I was like, okay, yeah, like that's programming, there's all that, like that's what I'm interested in. And as I worked more and more on like the software side of things, like I was like working with hardware in tandem. My freshman year project was working on like a PCB, like the code for a PCB. That sort of helped me not be scared of the hardware side of things. And then this year I sort of I discussed with my lead first what projects were available. And this was a new project this year that we decided to implement because of a bunch of pain points that we had last year. And because of that, this was just like something that seemed really cool to me because it was something that we'd never done before and it seemed a really good place to grow. So that's why I decided to do this project.
Yeah, that's so cool. So you also built a hardware in the loop testing framework. For someone who doesn't know what that is, what problem is that trying to solve and how do you implement that?
Yeah. So I like to explain that side kind of by saying it's not easy to test everything on your car, right? It's very challenging. There's a lot of external variables that could go wrong. So what hardware in the loop does is it sort of isolates everything down to whatever specific parts we're trying to test. For example, we're running the most important PCBs that we need in order for the car to drive on the hill setup. So that sort of we're faking everything else. And we're like telling all of these boards like that they're experiencing all these conditions that the actual car would see so that we can kind of see how they respond. And if we're changing anything in the code, then we can instantly see if it actually, works or if something goes wrong. And that's just a way to verify. Specifically, we want to use it to verify that our software isn't messed up. If we push a change to our software, we want to make sure that nothing can actually break on the real car. And, you don't really want to test that by immediately pushing it to the real car. So yeah, testing it on the hill setup first is kind of our goal for it.
If I understood correctly, is it a way for you to cross-check that what you're doing on the software side is working before you're actually implementing it into the real vehicle?
Yeah, pretty
Okay.
much.
Okay, cool. So you're also managing data from over 50 sensors on your car. Has there ever been a time where, the data that you've collected from your vehicle has completely changed how your team understood how your car is functioning?
I think that's a really interesting question. And they can also probably say a little bit on this because every single person on the car uses data to drive their design decisions. So I think there's never been anything from the data that has been extremely, oh my gosh, what is going on? It's like we need to completely change the design of the car. But there's definitely been times when, like, looking at the data from the sensors, we can see that like something is wrong or something needs to change and kind of using that to inform our decisions either next year or like moving forward if we still have the space to is something that we can use them for.
Yeah, that's super cool. What is one thing about like the software side of the car that you think the hardware or mechanical side isn't necessarily like thinking about during the design of the car?
There's kind of a tendency to almost take software, like, maybe not for granted, but like assuming this is fine, software can just take care of it. In terms of like, because there are like certain things that you can control in hardware versus software. And the default is kind of to just be like, if there's a problem in hardware, oh, it's fine, we can just fix it in software, which is, we do want to make sure everything works on the car, right? And if that means we have to sacrifice a little sleep to fix whatever issue there is, that's fine. But I do think there's a little bit of that sort of like assuming that like everything can be fixed with software.
Yeah, I totally understand what you're saying. I think I just mentioned a little bit earlier, I'm on an FRC team, but I'm on like the mechanical sub team. So I think I can definitely relate to saying mechanical definitely does take software a little bit for granted sometimes in terms of thinking they can fix everything that we do on the mechanical team. But yeah, we do appreciate you guys on software. Yeah. But yeah, that's all really, really fascinating. And that's incredible work that you're doing. You're building like the nervous system of the car almost. But Ariella, your job is to make sure that all actually fits and works together. So I'd love to get a little bit more into that. You built a transient heat simulation in MATLAB. What was that actually working to predict, and how does that impact the performance of the vehicle?
Yeah. So what basically one part of the integration subsystem is the cooling subsystem, like cooling project, which is very, very important. It basically allows our car to get the most power that it can and drive the fastest. And it's something that we've had a problem with for as long as we've been an EV vehicle. Basically, even if we can get more power out of our battery, we can't drive at that power because our motors and our inverter or simulator overheat. So that was a big thing that we looked into this year, was being able to set up those models in order to make informed decisions of how to optimize our cooling system to get the performance that we needed. So I did a lot of work on the data side this year to make that happen. And one of those ways was this transient simulation, which basically allowed us to predict the temperature of our motor, our motor and our inverter at any point in time across the entire race, which hopefully will allow us to go full power this year, which I think we're all pretty excited about.
Yeah, that's super exciting. But you were mentioning earlier that in high school you didn't do much on the technical side. So how did you end up in the subsystem, and how did you find your way into this technical aspect of the car?
Yeah. So I come from an interesting background. I'm very medical oriented. So I'm an emergency medical technician on the side, and I do a lot of medical related stuff. So when I joined the team, I wanted to do something ergonomics focused. So I joined the cockpit and control subsystem. And my sophomore year last year, I was the project lead for the steering system. So I owned everything from the steering wheel down to the rack and pinion system that moves the wheels of the car. From there, I finished that year and I was like, oh, I'm really looking for a challenge, and I want to understand the entire car as a whole, as a system itself. I think the biggest change was that I had always thought that the way to help people was to create medical devices. But through working on the team and through working at the steering, I realized that that's not the only way. So making reliable designs, making manufacturable designs, things like that can make a big change to the people around me. Specifically, manufacturability would help the people who manufacture our parts. I can see when I make a part that's easy to manufacture, their eyes are like, oh my God, this is so much easier. Or reliability saves the diagnostics team so much time in trying to debug the car. So I decided to look at the car from that high level perspective and make that change through other ways. So the integration team is really special because it touches every single other part of the car and makes sure that the car as a whole works at its highest performance possible.
Yeah, I think that's so cool that since your freshman year, you've been able to go through these different subgroups and work with different teams. And then, all of that leading to what you're doing now. That's really awesome for the integration team. You mentioned steering, so I'd love to touch on that. You helped build the steering system from the ground up. You guys welded it and ended up cutting weight by 25%. What was the hardest part of that process? Was it design or manufacturing or something else?
Yeah, I think that a lot of the times when you work with ergonomics, the hardest part is the battle between quantitative and qualitative. So when you're working on something that's purely structural, it's really easy to be like, oh, we can cut weight doing this, this, and this. And as long as it passes our FEA or our load cases, then it's fine. But when you're working on something like the steering system, our driver becomes a lot more important. And our driver, we can't really measure, we can't put him on a scale. Well, I guess we could, but it doesn't measure his satisfaction or like his drivability. So we had to basically create quantitative ways to measure his performance. So that was something that I worked a lot on last year, is be able to measure the success, how the changes I would make would affect our points in competition directly. And the way that we would affect our points is by making the car more drivable through the steering system. So that was really hard, but hopefully I made it.
Yeah, no, you definitely did. And yeah, I think ergonomics is sometimes like overlooked when it comes to vehicles, but I think that's super, super important. Like what you were saying, drivability of the vehicle. I mean, making sure your driver is comfortable and that everything is functioning to like their content. So yeah. But you're also managing more than 20 people across cooling, electrical enclosures, and suspension. So what does your week actually look like in the shop?
Yeah, my week is a lot of meetings, a lot of meetings. Something about not only being lead, but also being lead of integration, where communication and interfacing with other teams is so important. I spend a lot of my time talking to people and making sure that the decisions that we make, like the effects, are understood throughout the entire car and throughout the entire team. And this also includes meeting with my project leads and making sure that we're all on track to hit our deadlines and basically putting in as many hours as we can to make sure that we do that. A lot of nights at the shop, part of like being a lead is also being there for other subsystems. So for example, right now, all three of us are actually working on the high voltage battery. And so we're spending a lot of nights at the shop, just like working away and talking to each other at the same time. But yeah, putting a lot of time in.
Yeah, and integration is obviously so important because without that, all the different subsystems could be working very differently from one another. But having them all come together and form one vehicle is very difficult. So integration is really important. That's really cool that you're doing all that work. Dhrithi, you're working on what makes the car actually go fast, the powertrain. So can you tell me a little bit more about what that role entails and the work that you guys do in the subsystem?
Yeah. So I think if you talk to anyone who has a vehicle level knowledge of an SAE car, they will tell you that if I had to make one decision to make this car faster, usually you have the most opportunity in the powertrain. And it is not simply because it is the machine that makes the car go faster, but the design of it and your ability to locate the resources to better the design are both very limiting factors and also kind of govern how the rest of the car will eventually perform. So like an example would be one for most of our SAE teams, especially those in America, we are a bit limited on our actual choice of inverter, which is other word for a motor controller, and motor, which pair together. And so that can in and of itself kind of govern how you choose to design your vehicle. Whether you have a 2-wheel drive or 4-wheel drive vehicle will change where you choose to put your CG, how you choose to govern the dynamics of your vehicle across the track, and how you choose to approach the vehicle in a whole.
I think another example is this year specifically, one of the biggest changes to the powertrain has essentially been a lighter battery pack. And it wasn't entirely hard to achieve. So we, as a competition, have like a battery pack like voltage limit. And usually you have two characteristics of any battery cell that you can play with, and that is the actual voltage, which since most batteries are like a similar voltage, you can either change the number of batteries or change how many put in series and parallel and changing the overall charge or capacity. So last year we just ran a battery cell of a higher charge, and those obviously tend to be a little heavier. And so we are running a very efficient but with less overall capacity by getting a battery cell of a smaller charge individually. And obviously very easy way to save weight. But the sacrifice we're making in that decision is by assuming that this weight that we save is going to feed into allowing our car to output more acceleration per unit power that we're able to generate from our powertrain. And that is determined by how the rest of the vehicle is built. So if everyone else builds a heavier vehicle, or someone else builds a cooling system that is less capable of getting the most power out of our battery, then that could potentially be detrimental to the actual performance of the car. And you can kind of see this because last year, the car that won, which is GFR, is a very heavy but robust vehicle. So they are, there's a lot of mass to push, but they have all the power to push it. Whereas there's other cars that perform really well, like Georgia Tech, and they're the best at acceleration, which makes sense because it's a very weight-sensitive event. And they also excel on the track, but they focus more on being very lightweight and prioritizing efficiency. So there's also philosophies to the car that you need to think of. And once you think of a strategy, you need to understand how the powertrain will eventually drive the design of the entire vehicle and make sure that you guide it that way. So there's a lot of communication involved that way too, but there's definitely things to be done.
Yeah, I think something that I can kind of relate to that, one, like, I guess quote, but one saying that one of my mentors on my robotics team says is, you can't always be the best at everything, so you have to really be the best at something. So what you were saying, certain teams focus on acceleration versus being heavier but more robust. So it's, I guess, having that niche for your vehicle, what you're the best at. So yeah, that's really cool. That was really interesting, what you just said about your subsystem. But you were talking about the battery pack that you guys designed, and you mentioned cutting the mass. So I actually wanted to touch on that a little bit. You guys reduced the battery structure mass by 30%. What was your biggest takeaway or your biggest insight that helped you guys get to that lower mass battery pack?
We are a newly integrated electrical team. So even though we've had a lot of prior experience building a battery pack and integrating that into a well-performing vehicle, we haven't had the documentation to entirely pass down that knowledge and build on top of it. So while we obviously knew how to size a battery pack, there's still many other options available out there that we wanted to kind of weigh against to know to make the best battery pack possible. And so this means that we want a battery pack that obviously serves the philosophy of our car, the strategy that we're trying to employ, and also brings out all of the total power that we want from our car. So ideally, what everyone says is that you want your car to be tire limited. So the tire is what's limiting your performance. Your powertrain, your cooling system, everything is allowing you to perform to that level. In order to do that, you come across conflicting necessities to make a battery pack that is light, but also heavy enough to put the weight in your car where it needs to be. So you need to make it light, but also compact and integratable, and also something that's easy to service. A lot of different things come into play. And so you start thinking about, what is it I really need and what can I actually even change on this battery? And so to change your shape, you can change obviously the individual components inside your battery pack. And so there's most commonly pouch cells and cylindrical cells in EV battery packs. You'll see that a lot of industry standard car battery packs are made of cylindrical cells, and it's because they give you the advantage of scaling up in the actual charge of a cell and having a more efficient charge over mass ratio. Pouch cells are a lot more easy to integrate and manufacture with. And because we've ran with it before, we chose pouch cells again this year, because obviously it also matters whether you're able to acquire resource. But there's that, and also the consideration that making your battery pack lighter in different ways also affects the actual performance of your system. So for instance, if you had chosen cylindrical cells, by increasing charge, you would try to decrease mass by putting more cells in parallel and like reducing your overall pack voltage. And that affects how your motor controller and actual motors work, because the applied voltage changes the characteristics and efficiency at which your powertrain like functions. And so things like that are also things to consider and understand, so you know for the next years what are some resources that I couldn't acquire this year that I want to work towards acquiring for the next year, so we can get towards that ideal design.
Yes. Yeah. No, that was a great answer. It was very informative. So for that battery pack design, what would you say were the biggest trade-offs when you were thinking about how to design it?
I think the biggest trade-offs were always how much we want to risk our resources and timeline to go for this more ideal battery pack that we could possibly achieve. And the second was always time against mass. It doesn't sound as exciting as it, like, we might expect it to, but we can only design so much in like 6 months ish. We start our design kind of like right after competition ends, so we have approximately 6 months. So it's always somewhat like easy to figure out what your most optimal choice is, especially for something where you have limited options. But then you have to come into actually choosing how to package it into the car, where you can decrease mass, what is most ideal and most robust, and what is actually possible. And the greatest limiting factor is usually always time. So you have to understand that, because like even if you can save mass on your car, having more testing time gives you a better understanding to build the models and knowledge necessary to make it even better in the actual testing season or even for your next car.
Yeah, I think time is almost always like the biggest constraint when it comes to engineering and like designing. You guys have a lot of resources that you have to like allocate to certain expenses, but what would you say has been like the hardest decision in terms of powertrain or battery pack that you've had to make with limited resources?
I think the actual capacity of the hardest decision had been honestly choosing the cell and then kind of consequently how to package it. Not entirely having a good estimate of the capacity necessary for us to finish the race adequately kind of hurt us, since obviously we're building from not as much data and knowledge as we preferred. And so we spent a lot of this year building the tools and models necessary to have that moving forward so that we can implement in a design season, etc. But yeah, I think understanding that we don't have all the data necessary to back up our decisions made it a little difficult to exactly decide. But yeah, it was a little nerve-wracking, but we've made a choice, so we're gonna see how the car performs.
Yeah, well, that's awesome. Yeah, I think some of the best decisions often come from, just kind of having to make that spur of the moment almost decision, or like having to make that difficult decision between something that's comfortable and then something that you kind of have to explore like a new area for. I guess this is a question for all of you guys. What's something about having an electric race car that probably surprises people who think EVs might be easier?
I'll give the introduction because I do think they have other things to say. I don't think EVs are easier. I don't know if anyone thinks that really. Maybe there are complications in the construction of an IC car, but an electric car gives you the opportunity to just control so many more aspects with so much more precision. And also considering the fact that the mechanisms that which it works with, like circuits that drive like many more advanced technologies than an oil engine does, there's a lot more innovation on how you can compact that technology and use that to make a fast car. So I think there's just so much more to do there. And because there's so much more to do there, people eventually make more complex cars, and then there's more complex things to do. So yeah.
Yeah, I agree with that. I also think EV is the future, and a lot of who we are as a team and as people is trying to bring the next step into the world and like improve the world. This is like our way to do that is by using our competition and using like the other teams around us to keep growing more. EV allows us to do that, not only in like the resources that are available to us and like the customizations that we can do, which our team is pretty unique in like the amount of custom PCBs, custom configurations for our battery and things like that. And it just allows us to not only learn so much more about our components by making these customizations, but it also allows us to gain ideas on how to make them better and better and better. And when we go off into industry, we know that the information that we've learned from this team can help impact the future of EV and the future of the world in general.
Yeah. I think just to add on, the combustion kind of a flip side of the SAE competition, because there is a combustion side to it, has been around so much longer. Like people really know what they're doing, or there's a lot more resources available. And because EV is so fresh and new, there's a lot more innovation and learning, like really have to do on your own overall, I think. And there's a lot more components of the system that you have to think about. It's like if, we were combustion, like half of our subsystems wouldn't exist, right? So it's a lot less complexity. While there is still a lot of things to think about, there is a lot less complexity, I think.
Yeah, what you guys were mentioning about like these being the future is, I think that's so cool that you guys are making an electric like F1 car. You're working towards that future goal of having these kind of replacing ICE vehicles. I think that's really cool that you guys have an all electric vehicle, so you're able to make those new unbreaking discoveries on what it means to build an electric vehicle and how you're doing that. So that's really awesome. But shifting back to like full group questions, Formula SAE and Motorsport are still really male-dominated spaces. So what has your experience been like, and do you feel like things are changing right now in the industry?
I think this is sort of tricky to answer because it's sort of like the jump from going to like, I don't know, like 10% female to like 15% female. It is an increase, but then it's like, you're walking into a classroom and you're walking into a club and it's still like, wow, there's absolutely no woman. Because I had a moment, I think at the beginning of this year while we were doing introductory subsystem meetings, there was maybe one woman in the maybe or whatever meeting it was, and who was like interested in joining, right? Like, and that was like pretty like, wow, this is like kind of crazy. And I think because of that, like a really good thing that I've like seen happening and is like sort of like really important is like finding like a sense of community within the woman on your team. Like I think we're all like a pretty tight-knit group and we're all like really close to each other. So like sort of having that like is really helpful to like kind of not be scared away, I think. But yeah, I think there definitely has been more women at least interested. I think retention maybe is something that could be worked on a bit, but I think that's easy to say for anything.
Yeah, I think that for sure it's improving. Like, I feel like my class is testament to that because I'm in our history of a team, we have had one female president, and as far as I know, only one female technical lead.
So I
Sarah.
think it was Sarah.
Yeah. And this year we have 3 female technical leads, which is crazy. And next year, hopefully, the female technical leads are going to be like in upper leadership. So like we're like directly making the change. And I think that the reason for that is because we started out together and we were so close. So us two and the other girl who's in our year, who's the cockpit and controls lead, the 3 of us started literally first day we met when she came into the garage, and we stayed there till like 3 a.m.
I don't think it was. I think it was 2 a.m., but it
2
felt like 4 a.m. to us.
Yeah, really late. And from then on, we were a trio. And I think that us being so close just inspired people later on. Last year, especially when there were new freshmen joining, we tried to make a really big effort in creating those opportunities for women on our team. We have a channel on our communication platform called Women in Motorsports, and we did a Galentine's Day event last year, and we try to, include the freshmen and making sure that they have a community and really making them feel heard and understood that they have a place here. And I think seeing women in leadership, I hope makes an impact, and
Yeah.
we'll see the impacts bleed like later and later.
Yeah, I think that's so important what you said about creating that community and building each other up together. I know especially in STEM fields when there's less women, it's so important to all grow together so that, all together you guys can go into leadership positions or into those upper leadership positions and really make that change and see that growth in the community of women in STEM. And that's not something that anyone can do by themselves, so building that community is so important. So yeah, I love that. So kind of more on the technical side, competition day, what is each of your sub-teams' worst case scenario, and what does your prep look like going into that?
The worst case scenario would be what happened last year. And that would be water getting into the battery pack.
That's like my worst case scenario.
Well, I would be crying. I would be blaming her.
How did that happen?
Well, first of all, we're instated to have like a rain test because we are expected to drive in rain conditions if that ever happens. And so they do like a continuous pour of rain. And then you're supposed to walk out of it and then like, not have triggered any faults, such as the IMD fault, which says your entry system is shorted to the car. And so obviously water can help do that. Water seeps through our brake light mount that had broken.
Basically, the way that it broke is someone over-torqued a bolt, and the 3D print cracked.
Ideally, you want a waterproof EV car, and you did not.
I think also an important thing to keep in mind is one of the hardest things being on a team is like it's so easy to point a finger and be like, this happened because of this, but everything is an entire team-wide and system-wide failure, right? You can't really ever blame an individual, which is why it's so challenging, and it's also so nerve-wracking anytime you're working on anything that could go wrong, especially when it's like petition day.
But when things actually happen, obviously, anyone who is on the leadership team will know, obviously not make that.
Yeah.
It's understood that this is a team project.
Yeah. And I mean, after things happen, it's always a team effort to fix it and
Yeah.
get back to,
I
So,
think that like one major thing that we learned from last year is like how much the little things matter. I think like, a lot of the time as engineers, we get stuck up on like, we have to make like the best car possible, the fastest car possible. And we sometimes ignore like the little things, but sometimes those little things are like what make or break. And I think
Yeah.
that's like something that we've tried to do a lot is like make sure every box is checked. Literally like the attention to detail that we've tried to have this year, I think is gonna make the most impact rather than like any single decision. It's just like our commitment to all the details.
Yeah, and I think what you were saying, engineering is such like a compounding field. If one thing goes wrong, sometimes it doesn't affect everything. But then when like multiple of those things are building up, it just leads to a huge failure. So yeah, attention to detail is definitely extremely, extremely important. So what is one thing that each of your sub teams have been working on currently that you're really excited about?
We have finished bolting together. So we were using pouch cells, and to connect them, we simply just punch out holes in them and bolt them together. Sounds a little rudimentary, but that's what we did. Not most reliable. We feel like it is the most reliable way to manufacture for our needs, and we want a very modular pack so that we can switch out our battery cell if we ever need to. So, yeah, we just finished doing that. We just finished welding the steering system.
Good.
Yeah, we finished our Big Bird setup, or
What does
almost
Big Bird
finished.
mean?
Big Bird, so like she talked about Hill, we have this other thing called Hiddle, all very profoundly named. This one is hardware in the loop, and I know instead of just PCBs, we include the actual inverters and motors that we are going to operate the system with, and it also has all the other high voltage components necessary to make that happen. But we basically test again the software, but with the actual components drawing load. And I also want to make sure that the inverter and motors are working like how they're supposed to some extent. Obviously, it doesn't recreate all of the conditions, but yeah.
Yeah. Well, it sounds like you guys have a lot going on right now, so that's exciting. But I kind of want to talk a little bit about the bigger picture, future career-wise direction, I guess. But has being part of Formula SAE changed your career direction that you thought you were heading in at all?
I think I have like a pretty interesting answer to this because my major is technically information science and data science. Like I'm not technically an engineering major, right? But I'm getting a minor in computer engineering, and I mean that's because of Formula. Like my entire kind of like career path pivoted once I realized like, wow, I'm like super interested in all the things that are going on in the team. So that definitely was like almost a surprise because going into college, I was really like, I want to do data science. I want to do data science. I want to do data analytics, like all of that. And then I joined Formula and I was like, wow, I really like computer engineering. And like sort of Formula has also enabled me to follow that career path. Almost all of the opportunities that I've been able to get have been because of Formula, which have like really put me in a really good place for a career in computer engineering, which is something that I'm really grateful for the opportunity to actually be able to do, right? It's like the stuff I've been able to work on both for like my work and for Formula have just been so incredibly rewarding and interesting and like really put me on a really good path in life, I think.
Yeah, that's awesome. Well, I guess moving on then, Emma, you're going into embedded software and GNC at SpaceX, which is a pretty specific path. when, or I guess how did you know that was what you wanted to work on or the path for you?
I think, I don't know, a little bit of it is I'm still really scared for the work I'm doing this summer because I think I have a little bit of imposter syndrome, right? I'm like, why in the world did they hire me? Like, I feel like I don't know that much. But I think it's sort of like I have to like really like have faith that I know what I'm doing because, obviously, like I didn't get hired out of nowhere, right? I think sort of the control side is something that I've always really been interested in. And while I've kind of dabbled in some stuff, I think it's something I've really been kind of scared of. And having this opportunity is really going to push me down a path. As we were talking about, I think earlier, is being uncomfortable is where you grow, putting yourself in uncomfortable situations. And I'm really excited to be in that uncomfortable situation. And there's so many aspects of computer engineering that you can go down. There's embedded software, there's also controls for embedded. There's so much. And I think this is really helping me kind of inform what I want to do when I go full time.
Yeah, that's really exciting. Congratulations on that opportunity. That's amazing that you're doing that this summer. And good luck too. Ariella, you also have a very interesting thread running through your work. You were mentioning earlier you do medical devices, you're working on race cars, and then now to SpaceX. So is there kind of a common theme that you hope to connect, or are you still exploring your different options?
I think there is and there isn't. I think that the main thread connecting all of them is my want to help people. So as I talked about a little bit earlier, the way that manifests can be a little bit different, whether it's through making the most reliable manufacturable car possible for these guys that have to work on it, or making medical devices for specific use. Last summer, I worked at a dental engineering place where I made glue, medical adhesive for surgery, and was able to make changes that way. The main thread is that what I want to do is make an impact on people's lives. And I think that's something that I'm really excited to do this summer, is be able to have a direct impact on astronauts and, the people working on the rocket when we actually launch it. Like Emma said, it's a little nerve-wracking, but I think it'll be fun and it'll be good.
Yeah, I think that's amazing that you were able to, connect all these different interests, to your common thread of wanting to help people and still exploring so many different avenues within the field. That's really cool. And good luck to both of you guys. You guys are going to do great. And then, Dhrithi, do you know kind of what direction would you like to stay in? Automotive engineering, motorsports, research, academia? Do you know where you're kind of headed in your future career goals?
Um, I think I am the biggest fan of the culture we have on Formula, which might be a bit opposed to some of my other two friends, simply because we've talked about it. I think it would be interesting to work in either motorsports or startup or a company with a similar work value like Tesla or SpaceX or Edge or any one of the up and coming, very excited to work. In terms of what I do, I think there's a lot more that I can explore. I think I want to do more control specific, but on the testing and powertrain side would be cool.
I think that one common thread in us and in the other people in our team is the drive that we have. So the main thing I think that Formula teaches you is complete and utter ownership over your project. And no matter how many hours we stay up, no matter how many all-nighters we pull, we will make sure that our project gets done to the best of our abilities. And that's going into full-time work, going into internships. That's the same kind of energy we bring, is to get our stuff done and make sure it's the best product possible.
Yeah, and I think that's such an incredibly important quality to have in engineering and STEM in general, or really in any field, having that ambition and drive to do your best work, even when things are difficult or tiring or exhausting. And I've only been talking to you guys for an hour, and I can already tell you guys are super ambitious. So that's amazing. If you guys could go back and give your first year selves advice on Formula SAE, what would you say?
You guys are older. You should go first.
I think the main thing that I would tell myself would be that everything will be okay and ask the most questions possible. When you're young, when you're a freshman, and you don't have many expectations on you, that is your moment to learn the most that you can. Not saying that you can't do this later. You absolutely can. And I think that's something that's pretty cool about our team is I go up to her and I just grill her about battery questions because I want to know. Or she does the same to me about cooling, and we sit down and explain everything to each other. But when you're in your early years, you can learn so much, you can explore so much. And part of that is like what I was saying, being uncomfortable. And that's okay. And everything will be okay. And life will work itself out.
Yeah, I mean, I think what I would say, like, pretty much echoes the same sentiment. Like, do as much as you can. It's gonna be uncomfortable. It'll be okay.
You were saying about asking each other questions about your sub teams. I think that's so important just to know how everything works together. And I think sometimes it's easy to get stuck in just like your own sub team and just your own project, but it's so, so valuable to know what everyone else is working on and how those components work because it affects your own design so much. So, yeah, I think that's a great skill to have, especially in engineering.
Yeah.
Had some thoughts in mind. I think the first thing I would say is obviously to be more confident in myself. I feel like I've gone through phases on this team where as I got more responsibility and as I got to care more, I wanted my voice to be heard out there. And it was a bit hard when you, one, don't entirely believe in yourself, and two, also feel that imposter syndrome. And it's like a combination of like being generally a bit quiet, I think, and also being a bit different from the people who are on the team and the culture, just like part of being like one of the few women on the team. And so I would pivot from being overly defensive or being angry to be heard. And then eventually you understand to kind of cement yourself and make yourself just louder. It's like a whole like barrage of things. I think it all comes from believing in myself a little more. And I think the like pushing to the two extremes is kind of important to settle in the middle and know how to express myself properly. I think that was kind of good. And I think the second would be to have a little more routine and sustenance in my life, I think.
Yeah. Like Dhrithi was saying, we all go through like moments of like self-doubt and like self-deprecation and like feeling like imposter syndrome, like Emma was talking about. And I think that part of it is like our own belief in ourselves, and part of it is each other. Whenever like I'm having a bad day, I know that I can call at least the women on the team and be like, hey, like I just need like some common sense. Can you be my common sense, please?
I don't think you realize how hard the space is to navigate without people who are willing to talk to you. Because otherwise, you're surrounded by people who seem always confident. There's people I've asked themselves, I'm like, don't you have moments where you are confused or like buys yourself? And they're like, no. So it's really good to have grounded people I can talk to with honest.
No, 100%. And having those people that you can fully like be yourself and be comfortable expressing those times when you're feeling self-doubt is so important. Because, it's easy to have like a relationship with someone where you're always kind of like at that surface level, like you're having like good communication and stuff, but being able to like go to that next step and talk to them when you're feeling down or you're having a bad day, it's so important to have those people. And it's really great when women in STEM can like create that community for each other. So yeah, I think that's really great. Next, I just have like a quick little rapid fire round. So like just give me your first thought. Don't overthink it. What's your favorite motorsport, if any, to watch outside of Formula SAE?
I actually don't watch any outside of Formula. I like barely watch sports. I'll watch I'm from Boston, so I'll watch the Super Bowl if the Pats are in it, which they and then I'll occasionally watch figures too, but no motorsports for me really. When we first joined the team, we got pretty into Formula One, so we watched that. And now I watch a little bit. One of the members of our team, who's actually our driver, he works for NASCAR. So
Wow.
we'll watch the races with him when like his team is doing
That's so cool. Yeah, that's so cool.
Yeah, I don't watch that much racing. I think I watched F1 a little bit in the beginning, and then I tried watching them on NASCAR.
No, that's fair. That's fair. What's one tool, like it could be software or a physical tool, that you could not live without?
Excel. Excel, I hate MATLAB, but I do use it a lot. Excel. I think everything else is replaceable. Maybe Motec? I don't think Motec is that.
Ooh, Motec's a good answer. Motec is like the
I haven't
software.
used it for the irreplaceable features of Motec.
I've used it for the irreplaceable features. Motec is like the software that we use to analyze our data on the class.
Okay.
I feel like my answer is like more mech. It's the welder. We weld a lot of things, and I really like welding. I really like.
Yeah, that's a good answer. I like that.
I think for me it's a wire stripper, just because there's so many times you have to use wire strippers for like so many things. when I'm testing software, sometimes you have to like, break out some certain things, or like if we're making a harness, you have to use the wire stripper. So I think those.
Yeah, I love wire strippers, so I agree. If you had an unlimited budget, towards what part of the vehicle would you put it?
I would buy the best motors, buy the best batteries, cylindrical battery cells, sell them up to have some infuse them for us with custom-made modules and cooling.
Wow, you really have a plan.
Then I would buy all of the like actually on stock in shelf Toro that's in mint condition.
Always carbon fiber.
All of the best high strength modular.
You've thought this through.
All of the sensors.
Yeah, I was gonna say sensors. Like, I
Yeah.
feel like sensors are really expensive, and I feel like we can.
Maybe we'd buy someone
Yeah.
who can do the vector nav for us.
Yeah, I think something that's really interesting is like I think actually like putting that money into something that's like we tend to not allocate that much money for because it's not necessarily as necessary. Obviously, sensors we do spend a lot of money, but I think we could do a lot of really cool things with sensors that because it's like not top priority that we don't.
I would buy a CNC. It's like there's a lot more that we would be able to do in house if we had access to a five axis CNC.
Yeah, CNCs are amazing. They do so much. Okay, next question. What is the best thing about being on the team?
Community.
Yeah, community.
Yeah,
People.
I
That's a good
I have my best friends on the team.
That's sweet. What is the one thing that no one tells you about building a race car?
How many hours it is?
How many things it is also like
Maybe how much fun you'd have doing it.
I think so. Formula cars are not street legal.
We could make it street legal. We need turn signals. We need headlights. Yeah, we need rear view mirrors. We used to drive on the street though. We used to have like police.
Yeah, that's a step for.
That's really cool. Okay, well, last question. What is the one thing about being a woman in Formula SAE or engineering broadly that you want other young women to hear?
That it's definitely going to be hard. There's definitely going to be moments when you're like, why did they not listen? Like, why aren't they listening to me? And sort of like, it's hard. You're going to have to do a lot more extra work, which really sucks. And it's also sort of product of being in the field, but don't be scared to like speak up or say something or be confident in yourself.
Yeah, that and you will find your people. There's a very strong community for women in STEM, women in engineering, women in FSAE. Like even like when we talked to other teams during comp, like I remember there were 2 girls from Colombia last year that like I made really close friends with, and we like hung out a lot. And it was like a product of being a woman in a male dominated field.
I think to add on to that, something that we do so comfortably with our female peers, but not with sometimes the rest of the team, is to put ourselves out there in a way where we aren't so worried about how we are perceived. And I think it's really interesting because the women on the team, especially as they come in, I see, or at least I was affected by this personally. You want to feel like one of the boys, but that is not like being your true self, and that is not connecting. And also, they don't want you to be one of the boys, also, because you were not a boy. So yeah, you can be connected, but there's like a way of orienting yourself that allows you to be close to someone, person to person, that doesn't have to do with changing how you interact for a certain person or gender or like position or role, whatever,
Yeah, I think that's so important to like keep in mind. You don't have to always fit into a space because like as a woman in a male dominated field, inevitably sometimes you're not going to fit in the traditional way just because like by birth you're a different gender, and sometimes people look at you differently because of that. But you always have that like need to feel heard or to feel seen, but that doesn't have to come with changing who you are for that. So I think that's a really great message.
Yeah, kind of adding on to that, like it's okay to be girly, it's okay to be a tomboy, and it's okay to be both. And I think that that's something that like we try really hard to do. Is like there are times that we dress up because it's fun, and some guys on our team are like, "Why are you dressed up?" And we're like, "Because we want to." Like, what do you think?
No, I actually read something on that the other day about how women in engineering or STEM fields are always thinking like, oh, what should I wear? Like, should I do my makeup? Should I do my hair? Because they feel like if they're putting all that effort, it makes them look like they're girly or that they have like personality, and that makes people look down on them. But it's okay to like take that space and to express who you are by nature. And if that means you're girly, that's great. If that means you're a tomboy, that's also great. Like, it doesn't matter. You don't have to be perceived by people how they want to perceive you. So yeah, I think I really love that message. Thank you guys so much for doing this today. Like, I love talking to you guys. It was really fun to get to know all the amazing work that you guys are doing and just hear about your experiences. What you're building is genuinely incredible, and I think a lot of young women listening will feel the same way. And hearing your stories are definitely going to make them feel like they can do it too. So I really appreciate that you guys took the time to talk.
Yeah. Thank you so much for having us.
Yeah, thank you. And for everyone listening, if this episode resonated with you, please share it with someone who you think would enjoy it as well, and leave us a review on your favorite streaming platform. So until next time, keep persisting. But yeah, thank you guys.
Thank you.
Once again, I'm your host, Emma Zareen, and thank you so much for tuning in to today's episode of the She Persists podcast.